Hey everybody, welcome to the channel. This video is about building this, the Stretch, a 3D printed 1.6 meter V-tail glider. Available now on the SoarKraft website. We're going to print, build, and fly the Stretch. Thanks for watching. Please like and subscribe. And check out my other videos about printing, different materials and testing, and flying these SoarKraft designs to the limits of what's possible. This channel is funded by viewers like you purchasing my files on my website for printing planes just like this, and helps me to continue to refine, develop, and share new ways of making them better, faster, and cheaper to hopefully benefit everyone. Or at least to have a good time. Nice. This is the SoarKraft Stretch, a 3D printed 1.6 meter V-tail glider. This is an overview for printing and building the basic airframe. It builds similar to the other SoarKraft airframes, and this will have a two-piece wing and removable tail fins. And the wing uses 4 servos with inboard flaps. Here are the overall specs. The ready-to-fly weight is lightest for foaming lightweight PLA and heaviest for regular PLA, solid spar, and all metal gear servos. And this will be a heavy slope build in PLA Plus for windy conditions, but they all pretty much build the same. The Stretch flies great out of PLA and it carries the extra weight easily. The stiffer material makes for very crisp response, and it flies like a molded glider. I will be doing another print, build, and fly video for the Stretch in lightweight PLA with the Power Pod, so make sure you're subscribed, and it flies really well too. Alright, enough about that. Let's get started. While the Stretch is mostly made of 3D printed parts, there are still additional components that are needed to complete the airframe. There is a complete material list with the instructions. The new 1.6 meter wing uses an 8mm carbon spar as well as other carbon reinforcements to make a strong and stiff two-piece wing. The 8mm square carbon spar is available in lightweight square tube or very stiff solid square rod. I will include these sources in the description below, but you too can look for a local supplier by Googling Pultruded Carbon 1000 and look through the results. Shipping the meter-long carbon is usually the hassle, so getting all the carbon at once from the same supplier helps. The rest of the gear is pretty standard RC stuff. Lastly, the SoarKraft parts can be printed with any type of material, so then it's deciding which one. For this build, I've printed all of these parts out of PLA Plus, using PrusaSlicer and the SoarKraft configuration files for PLA with the nozzle temperature increased to 220 for PLA Plus. If you are using a Banggood X1C or P1S, find the PLA configuration in the file set or on the website. These are .json file type, and you need both filament and process. And import them, and they will show up in the user presets for filament and process. Select the SoarKraft process and the SoarKraft filament user presets, and make the nozzle temperature change for PLA Plus. Slice and look at the nozzle path for any given layer. If you see it extrude the entire airfoil skin first, then the interior structure second, then you know you are using the right process configuration. Bamboo Studio works exactly the same way, with exactly the same configuration files, to slice the same way. Even if you're not using a Bamboo printer, you can use PrusaSlicer and these settings for just about any printer to get good results with these SoarKraft parts. See my other video for how to transfer settings in SoarKraft. I do strongly suggest printing the test part first to dial in all the settings before printing multiple wing panels. I used Creality Hyper PLA Orange and Overture PLA Pro White, which is opaque and paints well. There are separate instructions for the fuselage and the wing, but each contain a list of every part that needs to be printed, as well as diagrams for where all the parts go. Using SoarKraft, I can load all the parts into one project for this stretch airplane. And because I am printing in PLA+, I can print multiple parts at a time. And in this project, I have it all set up by color. The majority of the wing in orange and all the other parts in white. The whole plane takes only 22.5 hours to print, and that's not even using the fastest print settings. With only 3 setups, the printer does all the work, with a little interaction to pull parts, change colors, and prep the print bed to go again. Yes, it's that easy. With all the parts printed and the Pultruded Carbon in hand, I can start building. Here are all the parts for building the wing. There's a wing diagram that shows where everything goes, as well as step-by-step instructions. The carbon fiber strips need to be cut to length. I use a white paint pen to mark them per the instructions, and cut them with a small bandsaw and a metal cutting blade. It only takes seconds, but you can use whatever process you want. Carbon dust is dangerous, so protect yourself. The leftover carbon strips from the wing will be used to build the tail, so save those pieces. I add paint before assembly, easier to mask. This is just a flat black couple coats. These 4-inch files are great for clearing any issues with the carbon channels. The PLA prints so clean most parts don't need any touch-up. But this is 3D printing, so every once in a while there's a goober where you don't want it. This round file works well for the spar channel. You can even work the carbon back and forth to loosen up the channel. Test fit all of the carbon to the wing panels. Work one side at a time. File and sand as necessary. The panels should fit nicely together. Slight gaps are okay. Make sure the carbon is below the surface at the center on both sides. Adjust if necessary. Fit the main square spar and the rear center spar, and test fit the 2 sides together. Check the fit and finish of all the joints and all the carbon, and if it's to your liking, you're ready to move on. Separate the halves and get ready for glue. Make a gap between the tip and the mid panel so you can access the carbon. And make sure the aileron carbon is in the right place and the other 2 strips are bottomed out. We're going to use thin CA to glue these in, and 3 binder clips to hold the trailing edge between panels. Standing on the tip, drip the thin CA down each carbon strip. A couple of drops each is all it needs. This will anchor the carbon strips in the tip, making the rest of the assembly easy. Then slide the mid panel down in place. Clean up any drips with a paper towel and clip the trailing edge. And make sure the leading edge is aligned and the panel seam is tight by pushing down. Repeat for the next panel. You can use the square main carbon spar for alignment, but don't glue it in place. If you're at all worried about it, you can remove it. Remove the square spar and glue the center panel carbon. Then set it aside and let it dry while you glue the other side. Exactly the same method for the other side. Glue, slide, clip. Remember, no glue on the main spar. And if you do end up with a larger gap between panels than you like, don't worry about it. You can fill it in later with a little bit of epoxy. I then stand the wing halves on the tips to dry. After a couple minutes dry time, add glue to every skin seam, top and bottom, on both wing halves. Don't glue the binder clip on, or your fingers. If you hold the wing with the leading edge down, the glue flows away from the clip, and then you can remove it. Then clean up any excess with a paper towel, and pull all the binder clips off. Touch up the glue on the trailing edge, and if you want, fill any panel gaps with 5-minute epoxy. Use a sharp knife to free up the ends of the control surfaces. A razor saw works too. With the ends free, grab the middle of the flap and just start bending it back and forth to get the hinge line to form. Repeat this until you get about 90 degrees down and 30 degrees up. Use a knife or a file to clean up any interferences with the seam cover to get a full 30 degrees up. For the aileron hinge, score the bottom with a file and bend it back and forth until it moves freely. Then with some silicone and a paper towel, we're going to coat the top and bottom of the hinge line. Wipe off the excess. You can use a Q-tip if your finger doesn't fit. Just a light thin coat on both sides, and it seals the gap nicely. Do this for all 4 control surfaces on the wing. Glue, wipe. With a new clean paper towel, you can clean up any excess on the hinge line. Let the silicone dry for about a half hour to an hour to skin over. Then exercise the hinges to make sure they move nicely. Clean up any globs that might be getting in the way. And now the wings are finished and ready for radio gear, and I can let them dry while I build the fuselage. Here are all the fuselage parts, including the leftover carbon from the wing. The 4x1 strips will be used for the tail fins. There is a part diagram and building instructions for the fuselage with a parts list. Some of the stretch parts are common with the other models, but to add length to the tail boom, the midsection was lengthened and split into 2 parts, but the same basic design. Same wing saddle, and an extender was added in front of the wing. Same tail section, and the same radio tray and nose cone, and the tail fins have been lengthened. So let's start by cut all the carbon to length and test fit everything together. Seams should fit tightly together, sand and file as necessary. I'm going to use the plastic T-nuts. Don't forget to thread them before you install them. You can use metal T-nuts if you want, but they do need to be modified. Plastic or metal wing bolts. I'm going to use plastic. Pop the T-nuts into the wing saddle. You can use one of the wing bolts to pull them into place if you need to. All 4 installed. Now that everything is test fit the way you like, we can start gluing. Let's build the tail fins first. The front 2 carbon strips should stick out about 16 millimeters, and the control horn carbon should stick out about 5 millimeters. With the leading edge down, you can tack the carbon in place without it moving. Then stand it on in and add more. Repeat for the other side. Score the bottom of the hinge line with a file. Then flex it back and forth. File more if you need to. Do the other side. Make it move nicely, but don't break it off. Then silicone again and a clean paper towel. Thin layer of silicone on both sides. Wipe off the excess, top and bottom, just like the ailerons and flaps. Clean paper towel to clean up any excess. Set aside to dry for an hour, then flex it to check it out. Fix any problems. The fins are done, so let's get back to the fuselage. We're going to mark the alignment of the radio tray, pull it out a little bit, then put the nose cone on, and it pushes the radio tray back to the perfect position. Pull the nose cone off, gently so you don't move the radio tray, and mark where it comes out of the other piece. You now know the maximum amount the radio tray can stick out. Next, tighten up all the joints and check to make sure the longerons are all the way in the tail. The longeron goes all the way back to the first fin carbon strip channel on both sides. A backlight can help see the carbon's position. Check the radio tray mark is still in the right place. And now you can mark the front depth location of the longerons in the radio tray, knowing it fits all the way back to the tail. So we can glue front to back. Make a gap between the extender and the wing saddle, and align the radio tray depth mark, and align the upper carbon so it just sticks out the front of the extender. Align the longeron marks. Add a drop of glue to anchor it in place. Both longerons and both upper carbon rods. Add glue to the overlap joint. You can hold it or add a clamp. Add more glue. Stand on the nose and drip glue down each of the carbon rods. Align the overlap. Add some glue. Then slide it together. Check the T-nuts are tight on the inside. Glue them in place too. On the back of the wing saddle, drip, drip, drip. Align, glue, slide tight, wipe off excess. Keep doing this for each joint and make sure the seam gap is even and tight. Last fit check of the tail section on the longerons, and the seam is tight. If it's not, now's your time to fix it. After dripping glue down the longerons and gluing the overlap, and a wipe, there's an opening in the carbon channel near the fins. Add some glue, and it will wick in, and then wipe off the excess. Do both sides. Now the fuse is done, and let it dry. After a good amount of drying time, you can test assemble everything. These parts should all remain unglued. However, you can glue the tail on if you want to, but don't leave these assembled for too long if they are just a couple of hours into drying. Several times I've done this final assembly late at night after gluing, only to find the parts permanently attached the next day. Especially the wing bolts, just tightening them can squeeze any uncured glue where you don't want it to be. Waiting overnight seems to work best. Here is the finished airframe, ready for radio gear, servos, and programming, and a flight test. But that'll have to wait until part 2, where I will finish this stretch. All files available at SoarKraft.com, and more build options coming soon, so please like and subscribe. Thanks for watching, and see you next time.